Now, hi Miles, how are you doing? Hope that you're having a good day. It's possible considering the day that, you know, oh good. Thank you. Thank you very much for asking. It's possible you might be the only person here, and that's fine. And if you have to leave at any point, then that's fine as well. I'm going to go ahead and I'm going to talk a little bit about another vitamin. And today, what I'm going to be talking about is none other than vitamin D. Now, vitamin D is a very important vitamin. Now, there's a number of things that kind of set it apart from other vitamins. And one of those is that, typically whenever you think about or learn about vitamins, they kind of have not necessarily a mind of their own, but they have what's the term I'm looking for? You have to get them from, outside, like you have to get them from your diet or something, or, you take one as a dietary supplement, instead of getting it from foodstuffs. But vitamin D is kind of unique because in order for it to be kind of worthwhile and useful, your body has to carry out a couple of reactions. Um, That's one thing that makes it unique. Another thing that makes it unique is that vitamin D, unlike, say vitamin C, vitamin D is a fat soluble vitamin, which is one of the reasons that, and I happen to have my vitamin D pills right here. If you get a vitamin D supplement, it looks like that. And, if you were to like get a needle or something like that and puncture the side of it and squeeze it, it'd kind of have like an ooze type of effect. Now, or it would have like an ooze kind of viscous, like oily type of appearance. And that's because it is a fat soluble vitamin. It is an example of a lipid. Now, and sorry, the components, if you ever look at the vitamin D bottle, what it has, other ingredients include extra virgin olive oil. Okay, so it's vitamin D in kind of a bunch of oils. Now, vitamin D was it was basically discovered by and isolated by this fellow over here on the right, which um, that looks like every picture of my grandfather before, like 1940. My grandfather was born in 1917. He's deceased now, but that's like what every picture of him looked like when he was younger. And that is not my grandfather, though. So he's credited with its discovery and its isolation. It is a fat soluble vitamin. And he is also credited with discovering vitamins A, B, and E. Now, he did this as a researcher at the University of Wisconsin, and he had, during his time there, a woman by the name of Marguerite Davis, shown here. Um, and Marguerite Davis worked alongside him for 5 years. And then in her sixth year, after he lobbied and talked to the university administration, said that, she's a valuable member of our team. We need to pay her. Finally, they said, okay, fine. We'll give her $600 for the year. So effectively, she got about $50 a month. But then if you were to extrapolate that out and say, okay, she worked for 6 years, she got $100 a year. She got basically $8 a year. And this was in like, I think it was 1920s to 30s area. And that's what she did. That's what they did. They were credited with isolating and discovering these different vitamins. Now, in addition to that, what they did was they studied rats. And now it's not too crazy to hear about, oh, well, this antibiotic is being tested, or, this drug is being tested before it's given to people. It's got to go through trials with mice. That's pretty standard operating procedure. Now, at the time, whenever they were doing this, however, this wasn't the case. They basically worked to, you know, collect and um, keep rats in like sanitary conditions so that they could study them and study them based on, if we if we give this particular nutrient to these rats, what happens? And when they developed these, what they termed rat colonies, one of the things that they studied was this substance called cod liver oil. So it was an oil that was extracted from the fish cod. And so they would basically have a bunch of cod and they would take their livers out and then they would extract an oil from it. Now, that cod liver oil, as it turns out, was very rich in vitamins A, B, D, E. And so that's where these vitamins ultimately came from. In their studies, what they were also able to do was basically kind of subject these rats to like 300 different diets. So by giving them these different diets, they were able to test different things. So this was like a pretty significant move forward in understanding nutrition, understanding how to study things, and not having to rely on, hey, I've got a friend who, if I give him $50, well, obviously not $50, but if I give him some money, he'll only eat this for a month or something like that, which kind of sounds like a challenge or YouTube challenge or something like that. But essentially, Elmer McCollum and his colleague, his understudy, his research associate, Marguerite Davis, that's what they did. They studied cod liver oil, and then they kind of took that cod liver oil and kind of diced it up. And they're like, let's separate it with this. So let's see what happens whenever we add this, what is separated out. And throughout all of this, and what they were studying, they kind of came to the conclusion that the American diet was low quality. And what they did was they pushed for organ meats instead of muscle meats. Now, whenever I think of organ meats and eating them, and someone saying, like, you need to eat more organ meats, I mean, my first thought is, like, what organ? And so then I'm thinking, like, probably not stomach, but maybe like liver. Um, And, if I can think of, and if anyone else can think of someone who like has gained like a high profile from being like, you need to eat organ meats, you need to eat maybe even liver, eat liver, eat liver, eat liver. Um, does anyone come to mind? For me, it does. And maybe this is just I'm on the internet too much. But that just makes me think of that guy who I'm not exactly sure where he's based. I think it's outside of the Dallas area, like Waxahachie or something like that. Nicknamed the Liver King. So in some respects, I'm going to go ahead and say that Elmer McCollum here was kind of like the Liver King before the Liver King was on Instagram and YouTube and I presume TikTok and every other social media platform. So Elmer McCollum was kind of the original Liver King. That's what I'm going to go with here. Now, keeping in mind that he was, the original Liver King, after he was at the University of Wisconsin, what he did was he later went on to Johns Hopkins University and continued study of nutrition. He continued to study basically what people eat and, how do they need to eat, like, and how much. And so he kind of put together this like baseline or like a boilerplate diet and, kind of came up with the essential constituents of an adequate diet. So far as these have been identified, we need to consume amino acids. Okay, that remains true to this day. We also need to get fat-soluble vitamins, A, D, E, and K. And then vitamins that are actually associated with water solubility. Vitamin C being one of them. Vitamins uh, B1 and B2. Essentially a handful of different vitamins that would be beneficial. So he comes up with this kind of lengthy list and basically this is a proposal that he comes up with. So essentially the guy Elmer McCollum who identified vitamin D was really a kind of pioneer of sorts of I guess you could call it like let's see like a molecular diet almost or understanding and trying to figure out I'm going to call it molecular nutrition. So, what are the molecules that make up a healthy or are healthy nutrients to have and to ingest? And, so after isolating and presuming here's all the things, Then he kind of went on and was like, okay, well, what are there foods that you can actually eat? And one of the things that he came up with was, well, you got to eat some eggs. You got to eat some leafy green vegetables, raw fruits and vegetables, meats, and um, and their equivalents and other foods of or animal origin. So he's kind of like this, advocate of eating like whole foods and real foods. And this is not like, hey, eat this as opposed to McDonald's, but it's worth noting. Now, what is vitamin D? That's the one that we're interested in here, and that's what we're going to be talking about today. Well, it is one of our fat-soluble vitamins. And I misspoke a moment ago and I said that B is a fat-soluble vitamin. I got B mixed up with K. So your fat-soluble vitamins are A, D, E, and K. Those are your major fat-soluble vitamins. And what that means is that if, again, with this vitamin D capsule, if I were to pop this and like drip it into, a glass of water, you're going to be able to see it. And what I mean by that, it's not going to mix well. It's kind of like whenever you get, a glass of water and you add olive oil or vegetable oil to it. It doesn't go into that solution easily. It doesn't go into that solution completely. Instead, it kind of stays separate and floats around. Now, this is unlike, or what makes vitamin D unlike other vitamins is that it can actually, in its functional form, be produced by the body. And in addition to that, it behaves like a hormone. And then this is the big thing that I've always known to be true in Central Texas and most of the United, not most of the United States, your southern United States. This synthesis of your functional vitamin D can be done with the help of UV light exposure. Now, typically, if you kind of pay attention to or if you've ever heard anything about, sorry, if you've ever heard anything about skin cancer, people will say, "Oh, well, your risk of skin cancer is higher if you are exposed to UV light more." And I don't think that there's any really doubt about that or argument about that. There's a very, very strong correlation there. Now, that's something that if you hear, you might think, oh, well, UV light is bad. Not necessarily. And as an example of that, vitamin D is beneficial. Or sorry, vitamin D is beneficial. And in order to get vitamin D in its functional form, you've got to have UV light exposure. So vitamin D itself has been implicated in a number of different things. One in particular is kind of an outdated disease. It's not outdated in that it doesn't exist anymore, but it's something that is a little bit less common. And this is a disease known as rickets. And if, I apologize, if someone is afflicted with or has rickets, what it's going to kind of appear as is it's going to look almost like they walk in a sort of bow-legged fashion. Um, Rather than here, I'm going to draw a person. Here's a rectangular torso. They've got legs like this. Somebody who is, I guess, has the disease state of rickets, they're going to look like this, that their legs are going to kind of have a curve to them. And this drawing is, yeah, this is just you know, my rendering. I'm not an artist. Um, In addition to that, vitamin D has been implicated in cardiovascular disease, cancers, autoimmune diseases, infectious diseases, neurological diseases, kidney diseases, and obesity. So it's kind of a catch-all in that it's involved in a lot of different things. And we're going to talk about this a little bit. But before we do that, I want to introduce you to our two major structures of vitamin D. They're shown here. These major structures are important. The first one is vitamin D2 or ergocalciferol, or there's a better way to say that, ergocalciferol. I'm not really good at saying that. And so what I want you to notice about this structure is we've got one, two, three. We've got three rings. Okay, those three rings are pretty significant for the structure of ergocalciferol. We've also got vitamin D3, which is the form that if you ever go and buy a vitamin D supplement, like what I've got right here, this is the form. The cholecalciferol is the form that is your vitamin D3, the kind of or it's one of the early forms that's relevant to people. Now, what we need to know about this is basically where that comes from. Now, I want to draw your attention to a couple of things. So, our different forms highlighted right here. I want to go to that one particular one, this 7-dehydrocholesterol. That's a molecule that we want to know about. What I've got elsewhere on this slide is basically the process by which it's produced. So this right here, acetyl-CoA, is a molecule that is involved in, or it's kind of a breakdown product for fats. Now, what I want you to see here is that this is showing that you need 3 acetyl-CoA molecules right here. If you have 3 of those, what you're going to be able to do is basically assemble this molecule right here, which is 2,3-oxidosqualene, which is this guy right here. So you're getting these 3 acetyl-CoA molecules. You're going through a bunch of different reactions, and you're going to produce this right here. So 3 acetyl-CoA molecules, which acetyl-CoA is going to be 2 carbons, and then this kind of bulky, what's known as a coenzyme. You're going to be able to put it together in this molecule right here, this oxidosqualene. So whenever you do that and you make this 2,3-oxidosqualene, you're going to be able to then make lanosterol and cholesterol, which is a steroid. So what I want you to take away from this, I'm going to go ahead and get my pen, is that essentially cholesterol, which, you get cholesterol from, if you go eat potato chips, they have cholesterol. Cholesterol is I'm going to say an intermediate in, let's see, cholesterol is an intermediate in vitamin D synthesis. Okay. So if you can make cholesterol, which your body can, you can get cholesterol from your diet, but your body can also synthesize cholesterol. And then your body's able to go through and make from cholesterol vitamin D. So what I want you to take away from this is this statement right here, that cholesterol is one of your major intermediates in vitamin D synthesis. I'm going to clear all my drawings out there, and then I'm going to go ahead and click next. So let's go ahead and go back to this 7-dehydrocholesterol. That was where we ended in the middle of the page here. So I want to go ahead and put a check mark. I'm not going to put a check mark. I'm just going to go on. So we had this cholesterol, which was made from lanosterol. The lanosterol can also be used, also in animals, to make 7-dehydrocholesterol. Okay. So what we're getting from this is what's known as a provitamin D3. And that provitamin D3, known as 7-dehydrocholesterol, I'm going to put a box around that. That's 7-dehydrocholesterol. That is going to be acted upon by UV light. Now, when you're looking at these structures, it might be pretty complicated. You might look at it and say, well, there's a ton of bonds there. I mean, there's a ton of, what am I looking at? Well, what we're looking at with this, sorry, I've got my 2 screens. They're normally not duplicated, but they are today. What I want to draw your attention to is of our 1, 2, 3, 4, of our 4 rings, one of them, with the help of UV light, opens up one of those rings. So UV light opens a vitamin Vitamin D ring. So the UV light takes our four-ring structure to now a three-ring structure. Now, the significance of that is that gives our molecule like a different kind of flexibility. It makes it kind of behave differently. No longer is it kind of restrained, but instead now there are parts of it that can move around, parts of it that can't move around. Now, from that vitamin D3, the three-ringed version, this pre-vitamin D3, well, we undergo this what's known as a thermal isomerization. I don't need you to worry about that title, but instead, what I want you to know about this is that vitamin D3, the stuff that well, that I just ingested, well, keeping in mind that what my bottle here says is vitamin D3 cholecalciferol. I believe, yeah. This guy right here, cholecalciferol. Okay, so that cholecalciferol is going to go into my gut, and then it's going to go into my bloodstream, and then it's going to go to my liver. And at my liver, what's going to happen is I'm going to add an OH, a hydroxide group. Now, when you look at this molecule right here, vitamin D3, and this molecule right here, the only difference is right here. So I do want you to know which hydroxide group is added first. The liver adds this hydroxide right here. And that hydroxide is found at carbon number 25. So I'll write my important statements right here. Liver adds OH at carbon 25. I change that to an L. It kind of looked like a 2. My second important item is, well, the kidney is going to take that modified form of vitamin D3 and give me my fully active form of vitamin D3, shown here. So the kidney adds OH at carbon 1. So here what we have is 1 alpha 25 OH2 because the kidney adds a hydroxide group and the liver adds a hydroxide group. The liver adds the first one, the kidney adds the second one. That's what I want you to know about the processing of vitamin D in your body. Okay. Now, here's another kind of rundown of that. I'm going to clear all my drawings. So the liver and then the kidneys. And, I think the way that that might appear as an exam question is, well, vitamin D is processed by which organs? Well, liver and kidney. And then another question or a separate question or a different sort of question would be, what's the sequence or what is the sequence in which vitamin D is processed by your organs? Well, the liver first and then the kidney second, which I guess kind of makes sense if you think about, what are your kidneys going to do? They're going to help everything get to your bladder and get, excreted from your body altogether. The liver is a major processor and a major detoxifier, but that's what the liver is going to do and the sequence it's going to work in. And then once you have that doubly hydroxylated form of vitamin D3, you've got a form that's going to kind of go on to the rest of your body and be able to work. Okay, so this is the important information that I want you to know about the metabolism of vitamin D. The liver works first, and then the kidneys, and then it can go wherever it needs to. Now, that's just kind of a continuation there. So, similarly, this vitamin D2 that I mentioned a little bit ago, that ergocalciferol, well, that's made in fungi and yeast, which yeast is an example of a fungus. Yeah. And these are both going to take place through UV light exposure. The synthesis is very similar to vitamin D3. I apologize. And one of the profound things that Elmer McCollum did was he worked with pediatricians at Johns Hopkins University, and he noted that when patients ate cod liver oil and or were exposed to sunlight, um, their symptoms of rickets basically kind of not necessarily evaporate. And I'm not exactly sure what that looks like in terms of it disappears. But the apparent symptoms were quite reduced. So the theory of rickets or your bone disease was caused by a vitamin deficiency was tested in rats, and then vitamin D supplementation and sun exposure were used as kind of a treatment. Now, in terms of what vitamin D does, okay, so we make it with the liver and the kidneys, but then what goes on? Well, vitamin D binds to what's known as a receptor protein. And I bring this up because if you remember when we were talking about cell signaling and a receptor protein and stimulating a response, well, vitamin D is one of those examples. So vitamin D binds receptor proteins or VDRs. Specifically, it binds one known as calbindin. Now, this binds another protein known as retinoid X receptor or RXR. Now, VDR and RXR bind to small DNA sequences, also known as VDREs. These are vitamin D response elements. Now, what this leads to is the expression of as many as 1,200 genes influenced by vitamin D. So you could think about this as vitamin D causes expression of, I'm going to say 1,000 plus genes. So vitamin D is not just some, casual trivial molecule. It causes the expression of different genes to be turned on. Now, this enablement this enables transport of calcium across the intestinal cells and into the bloodstream. So effectively, if you think about calcium and actually what's calcium used for? Well, one thing that it's used for is teeth health as well as bone health. And if you look at this bottle, which I'll show it on the screen, but might be tough to see. It's kind of in zoom or it's kind of in focus. It supports bone and immune health. It supports healthy teeth as well as muscle health. Um, I apologize. Goodness gracious. Now, the production of vitamin D3 is going to occur in the mitochondria within the cell. But what I want you to take away from this is this item right here. And so I might give you a question that says vitamin D causes or influences. I'll use that language in particular. Influences the expression as of, and I'll give you a couple of numbers, 100 genes, 200 genes, 500, 1,000. And, I'm going to look for an answer that's basically closest to kind of the Price is Right style, like which answer is closest to the correct answer. So if you said 100, yeah, you're not wrong, but that's not your best answer, or that's not the best answer. Okay. Now, with that in mind, I want to talk a little bit about, vitamin D changes the expression of lots of different genes. Well, what does it lead to? So, what I found was this paper that investigated vitamin D as a potential, I suppose I would say a potential not chemotherapy, but a potential therapy in cancer treatment. And so what I found was this paper that referenced using a high dosage of vitamin D in patients with advanced colorectal cancer. And this paper goes on to say that patients had a median delay of 13 months before their disease worsened. In the low dose group, in the median group, it was 11 months. And sorry, in the high dose group, it was 13 months. In the low dose group, it was 11 months. In addition, patients with high dose vitamin D were 30%, 36% less likely to have disease progression or death during that remaining 22.9 months that this study continued. So you could kind of think about it as I'm going to go ahead and use my drawing tool. I'm going to say LD for low dose, high dose. And I'm going to give myself a timeline here. So I'm going to say 13 months. And I'm just going to say, I'm going to give a frowny face. Oh, dang it, you did it wrong, Joel. Sorry. The low dose group, it was 11 months until disease state worsened, whereas in the high dosage group, it was 13 months. Now, an important thing to take away from this is, well, the number of people, um, it's not stated how many people were involved in this study, but that is significant to note. Then after this, basically the 22.9 months, what's not noted in the load, it said 36% less likely to have disease progression or death during the remaining 22.9 months. So you could kind of say that this is, well, 36% less likely to die. Um, I think that this is an interesting study. This is an interesting idea. A very fair question is how many people are involved in this study? What were the differences? Now, one thing that I think is worth noting is that we've got, I'm going to highlight this. Patients in the high dose vitamin D group initially took 8,000 IU a day for 14 days, then 4,000 IU a day for after. Now, okay, so this right here is 2,000 IU. So one of these is a quarter of what these people took. And for what it's worth, I take one of these like every 2 or 3 days. And the reason is that vitamin D, again, it can potentially be toxic. Um, Now let's look at, by comparison, our low dose group. The low or standard dose group took 400 IU a day, basically through the entire time. All patients were asked to not take another vitamin D or calcium supplement during the trial. Now, I think that this is kind of interesting to me because of the fact that, well, if you go outside, your body is going to be again producing more vitamin D. In this case, they're given a dietary supplement. Um, and I just think that it's kind of an interesting and arguably a pretty tough vitamin to study because you can't just say, okay, take this and, eat this specific diet. You can say that, but you also have to say, okay, eat this specific diet, take this specific dietary supplement, um, stay inside, or go outside for this long if you live here, or for this long if you live here, because UV exposure is going to vary from location to location. Um, but with that in mind, I think that it does present an idea of like, can this naturally occurring supplement be involved in and influence cancer? In addition to that, there's definitely a relationship to cardiovascular disease. Now, typically, um, you can get a lot of vitamins from different foodstuffs. There's a lot of vitamin D in something like salmon. But one thing that I want to highlight with this is that as at some point, eating and consuming a bunch of salmon could be a problem. Um, if you eat like a pound of salmon, a pound would be, let's see, 3 ounces. We're talking about five of these guys. If you eat a pound of salmon a day, you're going to be ingesting more than potentially more than what your body needs. This number right here, you need there's an RDA or recommended daily allotment, and then there's also a tolerable upper intake level. That's the amount where your body's like, no, that's too much. You need to stop. Where it's potentially toxic to you. So 600 to 4,000 is kind of the range that most people are going to ingest. And, some things like salmon or cod liver oil, they have a lot of vitamin D. So that's potentially kind of hazardous. Now, vitamin D supplementation and its impact on mortality and cardiovascular outcomes. This is a paper that it's known as a review article. What this paper did, or what the authors of this paper did, was they took all of the other papers about vitamin D and they kind of asked some questions. They were like, okay, well, we're going to look at these and we're going to analyze the results. And what they concluded was that they did what's known as a meta-analysis, sort of an analysis of everything that's out there. Um, the emerging results of our meta-analysis present evidence that vitamin D supplementation appears to decrease the risk of ACM or all-cause mortality while not showing a decrease in the specific cardiovascular morbidity and mortality risk. Thus, we conclude that further research is warranted in this area with a well-planned, executed studies as the basis for more robust recommendations. So this is pretty interesting. What they did was they said, well, let's look at this in one context. Our context was, well, cardiovascular disease. They looked at it that specifically. And then they kind of circled back and said, well, we're not really seeing that. We're not really seeing that it's preventing, cardiovascular disease from occurring, people from having heart attacks or strokes or anything like that. However, what we are seeing is that by and large, vitamin D does have kind of a benefit on its own. Now, what I think is kind of an interesting part of this, and it's not addressed here, and I can't remember if it is in the rest of the paper, but you know, if somebody is taking a vitamin D supplement, well, maybe they're particularly attentive to their health, and maybe maybe they're like, okay, I got to take my vitamin D supplement, and then I'm gonna go ride my bike, and then I'm gonna go lift weights, and then I'm gonna do this, and I'm gonna do that. So maybe that's a person who's just, paying a lot of attention to their overall health. And so maybe that's kind of maybe the vitamin D supplementation is kind of secondary, and primary would be, their sort of behaviors. Anyway, interesting idea. And this is a theme that I notice whenever it comes to studying or investigating different vitamins, and any sort of scientific study for that matter. You got to be very attentive to like the design of your study. Now, here's another one that investigated cardiovascular disease. And ultimately, what they kind of concluded wasn't too far off from the previous one. Um, no benefits of vitamin D supplementation for cardiovascular disease have been confirmed. And based on that, what do they conclude, or what do they kind of suggest? Well, more work is needed to establish any sort of protective role of vitamin D. It's kind of like saying, does it work? Does it help? Maybe. Right now, we're not seeing that it does, but that doesn't mean that it doesn't. That just means that we haven't seen what it does or what positive thing that it does. Now, there are some things that I noticed in this. This kind of relates to that RDA, that recommended daily amount. A low vitamin D status could be associated with a depression after a stroke. So this was a study where they looked at patients who were recovering from a traumatic brain event or a stroke, and they found that when those patients who were recovering from a stroke had low vitamin D concentrations in their bloodstream, that they were more prone to depression. Now, vitamin D is something that is also kind of implicated in geographic locations. If you've ever heard of seasonal affective disorder, that's where somebody like, I think that it's most common or most associated with people who live in the Pacific Northwest and like the Seattle area. During the winter months, your days are really short. You don't get a lot of sunlight. And so that can cause people to, be depressed. And really, it's mostly the entire northern United States that has that limited amount of sunlight. And they have a greater risk of not gaining all the, or not getting all the vitamin D that they need. So ultimately, vitamin D is implicated in a couple of different things. What I want you, and there's a couple more slides here. Yeah, I'll go through. I'm going to skip over this kidney health, um, and instead go on to what is vitamin D effective for. Um, it can be effective for, well, one thing that has kind of been implicated is rickets. So by taking vitamin D orally, it can prevent rickets and the symptoms of rickets. Um, there are also some instances of thyroid diseases um, that can help people with lower thyroid hormone levels. Then when it comes to what is it effective at kind of treating or being involved in, well, one thing is with respect to the immune system, hay fever seems to reduce symptoms of hay fever in adults and children. Cavities. So in the event that you have, kids who have cavities in their teeth, well, taking vitamin D or 2 or D3, D2 being the one from fungus, it can reduce your risk of cavity formation. Then potentially heart failure. It can reduce risk of developing heart failure in some people, but it doesn't seem to help people who already have any sort of heart failure. So it's almost like a preventative measure. But if you remember when we were looking at that paper previously, it kind of said, well, there's more study that needs to be done. Um, so I think that whenever you're looking at and trying to think of, well, what is vitamin D helpful for? Mostly it's with things that relate to bones and your teeth. Those are things you're most likely to see it benefit from. Um, what it's possibly ineffective for, well, it's possibly ineffective for heart disease. Taking it orally might not really do anything to prevent heart disease or stroke. Giving vitamin D to people with low vitamin D levels who are already in the hospital, the critical illness isn't going to sort of bring them back. If you break your bone, well, vitamin D is not going to really help you prevent that. Um, or if you're at risk of breaking your bone, vitamin D is not going to really help you that much. High blood pressure, vitamin D doesn't seem to do much about that. Prostate cancer and tuberculosis also not likely to do something with. Um, in terms of amounts, well, um, most people who live in climates with lower sun exposure, so like the Pacific Northwest is a good example, they should probably take 25 to 50 micrograms a day. Now, with that in mind, when you get a vitamin D capsule or something like this, if you look at this, it says on the bottle, there we go. It came into focus. You'll see this unit IU. And then you'll also see on here, so for instance, one of these is 2000 IU. Then you'll see amount per serving, and it says 50 mcg. 50 mcg. This is actually kind of a typo. It's not a typo. It's instead just like, it's a, not acronym. It is a, let's see. Yeah, I think an acronym would be good. That's incorrect. So mcg is microgram, but really a microgram is this right here. UG is a microgram. Um, so this is all kind of your daily amount of vitamin D. If you take too much of it, if you do what's called mega dosing, it could be hazardous to your health. Now, what I want you to know about all this is I want you to know kind of the major things that it's involved in. I want you to know the organs that it's involved in or that are involved in processing vitamin D to get it to its active form. And then I want you to know that UV light, you you could think about this almost as like a sequence. You need the UV light so that your liver can act on it, so then that the kidney can act on it. So then you can form vitamin D that needs to be circulating throughout your body. Okay, well, that was that's what I wanted to share lecture wise for today in terms of like content. I also wanted to mention that on the Tuesday after the break, so that would be the 3rd, December 3rd at 2 p.m. We'll have an extra credit opportunity in our Zoom link. There will be one that's done at 2 o'clock, and then there will be one that will be homework, and that's I'm gonna send that out after that. And you'll have like 24 hours to do that. Other than that, though, you guys have a exam on the 5th. Yep, Thursday the 5th, and that's going to be just like your other ones. And then our final, I think, is I can't remember if it's the 8th or the 9th. I'll post an announcement. And I'm also going to be working on a review guide exam for this 5th exam and a review guide for your final exam. So you'll have those. Um, but I'm going to stop my recording or actually before I stop my recording, if there's anyone who ever wants to talk to me about their grade or grading or what they need to do in order to, bring their grade up, just let me know. I'd be glad to meet in a Zoom meeting and we can talk about that. Make sure that you're in good shape. You know what you need to do on the final or on the 5th exam, um, and we'll go from there. Other than that, I hope you guys enjoy your break and I hope you have a good one. Thanks for coming.